Hello students, in this video we will study elementary principle of inclusion and exclusion in permutation combination. What is this principle? In fact, this principle starts from set theory itself. Set theory में हमने कुछ formulas किए थे, वो समझते हैं. For that, let me draw first Venn diagram for some sets. This is our universal set, in which I am having these two subsets A and B. This is A intersection B. Okay. Now what is formula for number of elements in A union B? क्या होता है इसका formula? This is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. We are subtracting this. The reason is elements in this set are counted twice. Once while counting with number of elements of A and once in number of elements of set B. Since it is occurring two times here in this sum, so we are subtracting this because we want only once. This is inclusion and this is exclusion. Now let me add one more set. एक और सेट ऐड करते हैं C set like this. Okay, now what is formula for number of elements in A union B union C? This is equal to number of elements in A, number of elements in B plus number of elements in C. But in this addition, each intersection of sets taken two at a time has been counted twice. So we will be subtracting intersection of sets taken two at a time. So we have minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C. तो हमने ये माइनस कर लिया, पर ये सब्ट्रैक्शन करने के बाद ये जो एलिमेंट्स हैं, एलिमेंट्स इन सेट A इंटरसेक्शन B इंटरसेक्शन C, ये बिल्कुल चला गया. It is removed at all. The reason is these elements are counted here, here and here. Three times they added, and also they are counted here, here and here. That means three times they are removed, cancelled out. But we want elements of this set once. So we will be adding this. So we have A intersection B intersection C like this. This is inclusion, this is exclusion, and this is inclusion. This is the reason this formula logic is called principle of inclusion and exclusion. Now we can extend this idea for any number of sets. Suppose we have now n sets. So we have number of elements in A1 union A2 union A3 up to union AN. This is equal to number of elements in set AI. AI means any set A1, A2 or A3 up to AN. I am putting here sigma. Okay, how many terms will be there? There will be n terms, or we can say there will be NC1 terms. We will be adding number of elements of single sets right from set A1 to up to AN. Minus, now we will be subtracting number of elements of intersection of sets taken two at a time. जैसे मैंने यहाँ पे किया है ना, दो सेट्स का intersection मैंने माइनस किया. So we will be subtracting here number of elements in AI intersection AJ. Okay, I am putting here sigma. How many terms will be there? दो सेट्स के intersection के कितने terms आएंगे यहाँ पे? Since there are n sets, I will be selecting any two sets at a time. So there will be NC2 terms. एक बार A1 A2 आएगा, एक बार A1 A3 आएगा, एक बार A1 AN आएगा. Then we have 2 3, 2 4, 2n, 3 4, 3 5 up to 3n like that. And the last will be AN minus 1 AN. Then we will be adding this one, AI intersection AJ intersection AK. I am putting here sigma. This is intersection of sets taken three at a time. How many terms will be there? There will be NC, 3 elements. Then We have subtraction of intersection of 4 sets, then we have addition of intersection of 5 sets, like that. Okay, this is up to minus 1 power n minus 1 multiplied by number of elements in A1 intersection A2 up to intersection AN. Here we have intersection of all sets. I have here minus 1 power n minus 1, and this depends on value of n, whether it is plus 1 or minus 1. If I put n is equal to 2, when n is even, I have here minus sign. When n is equal to 3, we have intersection of 3 sets, then this is minus 1 power 2, which is plus 1. So we can see here we have plus sign here. So this is general formula for number of elements in a union of n sets. This is inclusion, this is exclusion, then this is inclusion, and this is up to last term, like this. Now let's use this principle in permutation combination. चेक करते हैं permutation combination में ये कहाँ पे यूज होता है. Okay, let's do this question. Find number of integers from 1 to 1000 which are divisible by at least one of 2, 3 and 5. हमें इंटीजर्स निकालने, नंबर ऑफ इंटीजर्स जो इनमें से एटलीस्ट किसी एक से डिविजिबल हो. So let's now first of all create sets. Set A is a set of integers which are divisible by 2. Set B is integers which are divisible by 3, and C is set of integers which are divisible by 5. Now I want integers which are divisible by at least one of 2, 3 and 5. So I want elements of this set A union B union C. यूनियन का मतलब क्या होता है? एटलीस्ट. इंटरसेक्शन का मतलब क्या होता है? एंड, है ना? द मीनिंग ऑफ दिस A union B union C is we are looking for those elements which are divisible by at least one of 2, 3 and 5. Now this is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B, then B intersection C, and then A intersection C, and finally we have addition of A intersection B intersection C set elements. Okay, now how many elements in this set? How many integers are divisible by 2? Exactly 500. Okay, half of the integers from 1 to 1000 are divisible by 2. Those will be even. How you get this? Integers divisible by 3. See, there is a one shortcut for this. You divide 1000 by 3 and take integral part of this. This is equal to 333. So this is 333. Or you can do this way. The first integer which is divisible by 3 is 3, next is 6, and then 9. The last will be 999. Now this is an AP having first term 3 and common difference 6. The last term is 999. You can count number of terms in the AP. Okay, now how many elements in this set? Set C. Integers divisible by 5, there will be exactly 200 integers divisible by 5. Now this one, integers divisible by 2 and 3, that means integers are divisible by 6 because 2 and 3 are prime numbers. So how many integers will be there? We will be dividing 1000 by 6. So this is equal to 1. Then we have 6.66 like this, and the integral part of this is 166. So here there will be 166 integers. Okay, now elements in this set, number of integers divisible by 3 and 5. That means integers must be divisible by 15 because again 3 and 5 are prime numbers. So what I do, I divide 1000 by 15 and will take integral part of this, and this is equal to 66. So here we have 66 integers. Okay, this one, integers divisible by 2 and 5, that means divisible by 10. There will be exactly 100 such integers, plus this one, integers which are divisible by 2, 3 and 5. That means integers are divisible by 30. So I will divide 1000 by 30. So this is equal to 33 point something, and integral part of this is 33. So I have here plus 33. So this is equal to 734. There will be 734 integers which are divisible by at least one of 2, 3 and 5. तो आप चेक कर सकते हैं कि किस तरह से हमने यहाँ पे सेट थ्योरी का कॉन्सेप्ट यूज किया. इनफैक्ट हमने प्रिंसिपल ऑफ इंक्लूजन एंड एक्सक्लूजन यूज किया टू काउंट दिस नंबर्स. Now how many integers are there which are not divisible by any of these three integers? So number of elements of required set, integers not divisible by 2, 3 and 5. This is equal to, I will take the complement. That means this is equal to number of elements in a universal set. That means we have 1000 integers minus number of integers which are divisible by at least one of 2, 3 or 5. So this is equal to 1000 minus 734. This is equal to 266. So there will be 266 integers which are not divisible by any one of this 2, 3 or 5. In fact, this is a complement of this sets. What is complement of integers not divisible by 2, 3, 5? The complement will be integers which are divisible by at least one of 2, 3 or 5. Let's take one more question. Okay, question है find number of permutation of letters A, B, C, D, E, F, G taken all together if neither CAD nor bag pattern appear. हमें वर्ड्स बनाने हैं इन 7 लेटर्स को यूज करके जिसमें CAD एंड बैग नहीं होना चाहिए. So let me first of all write the letters A, B, C, D, E, F, G. First of all, how many number of permutations? If I take all letters together, then how many words I can form of 7 letters? The number of words formed will be 7 factorial. But in this 7 factorial, there will be words having CAD, there will be words having bag, there will be words having CAD, bag both. For example, if I take a word CAD, then I'm blocking this CAD, then I have suppose BFGE. Okay, so this word is not allowed. The reason is here CAD is occurring. If I take a word BEG, I'm blocking this B, E and G. So next letter may be A, C, D, F. This word is also not permitted. The reason is here bag is occurring. कुछ ऐसे भी वर्ड्स होंगे जिसमें बैग एंड कैड दोनों ही पैटर्न अपीयर होंगे. फॉर एग्जाम्पल CAD, BEG and here we have F. Here CAD and bag both are occurring. These words are not required. So I will be subtracting this words number of words from 7 factorial. Now suppose I want to formulate this, so I will take a set A. A is a set of words having CAD pattern. B is a set of words having bag pattern. Okay, now I want words in which none of this pattern occurs. That means I want this set A dash intersection B dash. I want number of elements in this set. Okay, now from set theory, this is equal to number of elements in A union B dash. डी मॉर्गन्स रूल जो होता है वहां से ये हो रहा है. दिस इज इक्वल टू नंबर ऑफ एलिमेंट्स इन यू माइनस नंबर ऑफ एलिमेंट्स इन ए यूनियन बी. Okay, so this is equal to number of elements in U minus number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay, now number of elements in universal set. Universal set means a set of words in which there is no restriction. उस टाइम पे कितने वर्ड्स बन रहे हैं? देयर आर 7 फैक्टोरियल वर्ड्स माइनस नंबर ऑफ एलिमेंट्स इन सेट ए इज अ सेट ऑफ वर्ड्स हैविंग कैड पैटर्न। जब वर्ड में कैड पैटर्न आ जाएगा तो मैं यहाँ पे इसको ब्लॉक कर लेता हूँ। ये जो लेटर्स हैं ये इसी ऑर्डर में होंगे, दिस लेटर्स विल बी इन दिस order only. Now the remaining 4 letters and this word CAD can be arranged in how many ways? This can be arranged in 5 factorial way. इस word के अंदर कोई arrangement नहीं होगा because we want CAD only, not DAC or ACD or DCA. Okay, so this is 5 factorial. Similarly, this is also 5 factorial because if a bag pattern appear, then this word bag and this 4 letters total 5 objects can be permuted in 5 factorial ways. Minus this one, words in which bag and cat both occurs. So we have now here cat and bag and this letter F. Now we have here 3 objects. These 3 objects can be arranged in how many ways? In 3 factorial ways. So this is minus 3 factorial. So this is equal to 7 factorial minus 2 times 5 factorial plus 3 factorial. So this is again one elementary question but very fundamental question from principle of inclusion and exclusion. Let's take more examples. Okay, this is next question. Question is find number of n digit numbers which contain digits 2 and 7 but not digits 0, 1, 8, 9. Let's first of all list down 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now number does not contain any of these 4 digits 0, 1, 8 and 9. So I am blocking this 0, 1, 8 and 9. So we have now only 6 digits. We have to form numbers in which 2 and 7 must occur. Okay, now we have to form number of n digits. So let me create n places for n digits like this. This is nth place, first place, second place, third place, fourth place and this is nth place. Now we have only 6 digits available. First of all, how many numbers can be formed when there is no restriction? Obviously there will be repetition here. यहाँ पे repetition होगा. The reason is digits हमारे पास सिर्फ 6 हैं and यहाँ पे जो नंबर है वो कितने digits का है? n digits का है. तो फिर n का वैल्यू जब 6 से ज्यादा हो जाएगा, if n is more than 6, definitely there will be a repetition. And if something is not given in the question, if some condition is not given in the question, it is assumed that there will be repetition because we always go for maximum answer. Okay, now this first place can be filled in how many ways? 6 ways with any one of this 6 digits. Similarly, second place we have 6 options, here also 6 options, here also 6, and for last place also we have 6 options or 6 ways we can fill up this last place. So total number of ways are 6 power n. These are number of numbers when there is no restriction. But in this 6 power n number of numbers, there will be some numbers having no 2, there will be some numbers having no 7, there will be some numbers having no 2 and 7 both. So we will be subtracting those numbers, those cases from 6 power n. So we have 6 power n minus. Now let's first find numbers which do not contain digit 2. अगर नंबर में digit 2 नहीं आएगा तो कितने digits बचेंगे हमारे पास? सिर्फ 5 digits. At that time number of numbers will be 5 power n. Similarly, those numbers which do not contain digit 7 will also be 5 power n. तो हमने ये दोनों केस माइनस कर लिए, पर ये दोनों को माइनस करने पे वो केस जिसमें 2 and 7 दोनों नहीं आएंगे, those numbers in which 2 and 7 both do not appear, वो केस कितनी बार माइनस हो जाएगा? 2 बार माइनस हो जाएगा, once in this and once in this. So we will be adding the cases when number does not contain 2 and 7. So if I block 2 and 7 also, so I am now left with only 4 digits. So numbers which do not contain 2 and 7 will be 4 power n. So here also we have principle of inclusion, then exclusion, and then inclusion. Let's take one more question. Okay, now question is find number of 11 letter word that can be formed using all the letters of the word examination if alike letters are never adjacent. इसका मतलब ये है कि जो सेम लेटर्स हैं वो एडजेसेंट नहीं होने चाहिए, साथ में नहीं होने चाहिए. What we do in this type of question? First of all, we segregate the letters. We have letters E, X, A, M, I, N, A, T, I, O, N. We have letters A, I, and N occurring 2 times. Total letters are 11. Okay. Now what is the condition? We want words in which alike letters are never adjacent. यानी कि A साथ में नहीं होना चाहिए, I साथ में नहीं होना चाहिए, N भी साथ में नहीं होना चाहिए. Okay, let's do this using set theory formula. For that I will be defining some sets. Suppose set P is a set of words in which A are together. A and A are adjacent. Similarly, Q is a set of words in which I occurs together, and R is set of words in which N occurs together. Now I want words in which A are not adjacent, I are not adjacent, and N are not adjacent. That means I want elements in this set P dash intersection Q dash intersection R dash. P Q R में से कुछ भी नहीं होना चाहिए. इसका मतलब P का कॉम्प्लीमेंट. P सेट कौन सा है? वर्ड्स इन विच A अकरिंग टुगेदर. तो P डैश क्या हो जाएगा? उसका कॉम्प्लीमेंट होगा जिसमें वर्ड्स कौन से होंगे? जिसमें A साथ में नहीं आएंगे. सिमिलरली Q डैश is a set of words in which I's are not occurring together, and R dash is a set of words in which N's are not occurring together. So I want P dash intersection Q dash intersection R dash, and this is equal to number of elements in set P union Q union R dash, complement of this, and this is equal to number of elements in set U minus number of elements in set P union Q union R. So this is equal to NU. फॉर्मूला से करने से कई बार क्वेश्चन आसान हो जाता है. This is NP plus NQ plus NR minus P intersection Q minus Q intersection R minus R intersection P plus P intersection Q intersection R, like this. NU, number of words when there is no restriction. There are total 11 letters in which we have 3 pairs. So this is equal to 11 factorial upon 2 factorial 2 factorial 2 factorial. Okay, minus this one NP. NP means words in which AA is occurring together. So I club this AA. मैंने इसका एक ग्रुप बना दिया. Now I have this 9 letters and this group. That means I have total 10 objects. How I will arrange this? This is equal to 10 factorial upon 2 factorial 2 factorial. Similarly, Q is same. 10 factorial upon 2 factorial 2 factorial. R is also 10 factorial upon 2 factorial 2 factorial minus this one P intersection Q. The meaning of P intersection Q, those words in which 2 A's are occurring together and 2 I's are occurring together. So now I have these 2 groups and 1, 2, 3, 4, 5, 6, 7 letters. 7 letters and 2 groups. That means there are total 9 objects. How I arrange this 9 objects? Arrangement will be 9 factorial divided by 2 factorial because of this double N. Similarly, each of this 2 will be 9 factorial upon 2 factorial. So I will be subtracting this 3 times plus this. This means those words in which No two A's, no two I's and no two N's are occurring together. So we make this 3 groups. Now I have this letters E, X, M, T, O, 5 letters and 3 groups. That means total 8 objects. I can arrange this 8 objects in 8 factorial way. So this is the answer. This is equal to 11 factorial upon 2 factorial, 2 factorial, 2 factorial minus 3 times 10 factorial upon 2 factorial, 2 factorial plus 3 times 9 factorial upon 2 factorial minus 8 factorial.